And good evening, everybody. Welcome to part three. Welcome to part three of a four-part series entitled Help, I'm Teaching Math. Again, we're not implying that you need help if you're watching this, but if you are being asked to teach math for the first time this year and you've never done so and you're freaking out, or maybe you are a veteran teacher, 30 plus years, or maybe you just finished student teaching and are starting, you've heard about Mathigon, you've seen Mathigon, but you've always wanted to learn more about it, tonight's broadcast is the night for you. You're going to love it. Hashtag learn today, hashtag use tomorrow. Mathigon is awesome. My name is Tim Brzezinski, and I'm delighted to join Deidre Baker on behalf of the Iowa Council of Teachers of Mathematics, who is sponsoring this free event, along with Dave Porras and Ada Adamir, who are going to be our dynamic, awesome presenters tonight. We are excited to have them in the house. But before we even get started, Deidre, do you have any few words you'd like to say on behalf of ICTM?
No, Tim, we are just so excited to sponsor this whole series of how to use technology in your classroom right now. I can hardly wait to learn more about Mathigon. Let's get going.
Let's get going. All right. So Deidre and I are going to hide behind the scenes. If you in the comments, if you're watching on YouTube, if you're watching on Facebook, if you could just say hello, let us know where you're from, what you teach. That'll be awesome. We would love to hear from you. Love to see you. If you have questions in tonight's broadcast, throw them in the chat. If we see a lot of questions with a common theme, we'll interrupt Dave and Ada and we'll ask those questions. We'll put them right up there on the screen. So don't be bashful. Don't hesitate. We would love to see you. Hello from Mexico City. We're just coming all in from all over. This is awesome. So without any further ado, Dave, Ada, welcome, and thank you for doing this. Let's get started.
Oh, thank you. Hi, I'm Eda Aydemir. I was a middle school math teacher for 16 years. Now I work as a curriculum developer and amplify in Mathigon. My specialty is creating content with PolyPad. And I should say I'm very excited to be here with you and Dave now. And I'm based in California and schools are started here, despite of the fact that it's being 100 degrees outside. So I just wish everyone a great start to the new year. Welcome again.
Hi, everyone. I'm David Porras. I am on the content team at Mathigon as well. I've taught 7th grade math outside of Boston for about 22 years now. Really excited to be here tonight to talk about how to use the tools on Mathigon to help students engage in mathematical exploration and discovery. Thanks to Tim and the Iowa Council of Teachers of Mathematics for putting this together. Tim, if you want to pull up my screen, that would be great, and we can dive in here. Thank you so much. Here's a slide deck. All of our slide deck and our links are available at mathigon.org/talk. Here's that link, mathigon.org/talk. You can head there. You can get a copy of the slide deck, all of the content that we're going to be sharing. There are links there to everything that we are sharing. So you could have that up in a browser if you want to follow along. You don't need to have a copy of the slide deck. More what we'll be doing on Mathigon might be a good thing to try to follow along with. I'm going to jump to Mathigon in a minute here, but really the theme of our talk is going to be, what are some of the benefits of virtual manipulatives? When would you choose to use a virtual manipulative in class over a physical manipulative? There's so many awesome things on Mathigon that we are excited to show you. Of course, there are times where a physical manipulative is best to use in class. And so like all technology tools, it's about being thoughtful in that lesson. What's the best tool for this lesson? And there's a number of categories where we believe that virtual can add value on top of the physical, and we're excited to share some of those with you tonight. But before we dive into these categories, I am going to do a quick tour of how to use the tools on PolyPad. So then when we get into these categories, you have a little bit more sense of how to engage with all the tools. So with that, I'm going to head on over to mathigon.org. So we think of ourselves as a mathematical playground. We have free tools, courses, and manipulatives to, as it says here, make online learning more interactive and engaging than ever before. And the main feature on Mathigon that we're going to be spending the vast majority of our time in tonight is PolyPad. 2 ways on the website to get to PolyPad. There's a button right at the top that can take you to PolyPad, or there's this blue button that says Launch PolyPad. I'm going to click that. and I have launched PolyPad. It brings me to this white open canvas. We call the white space a canvas. I like to think of the canvas as just an open place for creating, discovering, and exploring mathematics. And so I'm going to give you a quick tour of the canvas, and then I'll turn it over to Ada, who's going to dive into some examples, and then we'll get at the 4 categories on the screen and share some examples there. So just to give you kind of a tour of the canvas, there's a toolbar at the bottom that has a pen tool, a drawing tool, construction tools. This I'm going to be calling the toolbar. On the right-hand side of the canvas is a settings bar where you can toggle in and out of full screen and change the grid, all sorts of features. And then on the left-hand side of the canvas is our tile menu. You can see there's tiles tab, a file tab, and a class tab. I'll be talking about those over the course of the webinar as well. But let me start with tiles. I'm going to click on geometry to collapse that section. And you'll see here the 6 categories of tiles that we have: geometry, numbers, fractions, algebra, probability and data, and games and applications. So I'm going to go expand the first section of geometry again, and I'm going to click on polygons to show all the tiles in the polygon categories. So I've expanded the polygon categories. All of these categories can be expanded to see the tiles in that category. But let me go back to polygons, and I want to add a hexagon into my canvas. So this is the tile menu where I can find a range of tiles to put onto the canvas. And so now I'm going to add this hexagon onto the canvas. I just noticed a comment that some of you don't have the class tab. Absolutely. So that is if you have not made a teacher account or you don't have any classes yet, the class tab is not going to appear. And in about 15 minutes, we have a part of the webinar where I'll dive into the details about how to change account types and how to make classes to get the class tab to appear. So if that's not there on your PolyPad right now, no worries. And again, I don't know if I mentioned this at the beginning, everything on Mathigon is free. So everything we're going to be showing you tonight is free. The things we're not going to have time to show you is free for teachers, free for students, for everyone around the world. Okay, so I want to get a red hexagon on the canvas. So I'm just doing a click and drag, and you can see by doing a click and drag, I can put that hexagon on the canvas. I'm going to zoom in a little bit with the zoom in option over on the right in the settings. So I'll click that a few times to zoom in. The other way to get a tile on the canvas is I can just click on it. So here I just click, and there's the hexagon on the canvas. So let me get 3 on the canvas here. There's 3 hexagons. And you'll notice when a tile is selected, a new bar appears right underneath this. And this is what we call the action bar. So this is the toolbar. Here's the settings bar on the right, and this is the action bar. And we call it the action bar because there's a number of actions that you can do to that tile right in the action bar. One of the most common actions that you'll find yourself doing with tiles is copying tiles. And you can see I can copy this tile by clicking on copy, and there's a copy of it. There's a number of keyboard shortcuts in PolyPad as well, and the most common shortcut that I use is to make a copy, and that's just with the C button on my keyboard. It doesn't need to be Command C to make a copy on a PolyPad. If I just click C, I'm about to do it right now, there's a copy of it. So C makes a copy, and the other common action is delete, which I can delete by clicking that in the action bar, or I can hit delete on my keyboard. If I just hit delete on my keyboard, it's gone. So that's the action bar. There are some times where, depending on what you're doing, you want the action bar kind of out of the way. As you can see here, it appears underneath all of the tiles. If based on the task that you or your students are doing, you want to kind of keep the action bar at the bottom, there's an option to pin it here. So I'm going to click that, and it pins the action bar down at the bottom. I can unpin it to get it underneath the tile. So that's the general, like, what all these bars are about. The last thing to show you with just this hexagon is there's an action called cut. And so the actions for tiles are specific to the tiles that you have on the canvas. So because I have a polygon on the canvas here, one of the options is cut. So I'm going to click cut to show you how that works. You can see my cursor now has changed into this cross. And if I do a click and drag, I get a dotted line. And when I let go, I didn't let go in the right spot. Let me do that one more time. When I let go, I've cut that polygon into 2 pieces. And this like beautiful, easy way to cut polygons is such a powerful tool for a variety of mathematical explorations, which I'll be sharing over the course of the webinar. And so I could cut a number of polygons at once. I held down the Shift key to do a multi-select, and now I can do cut, and I can cut all of those at once into these pieces. How awesome is that? So if you're exploring the area of shapes, Pythagorean theorem, so many ways where the cut tool of area adds really a tremendous value to what students can do with a polygon. So that's the cut tool. Let me kind of scroll down the canvas a little bit. I'm doing a 2-finger scroll just to kind of like move down the canvas. I want to put another hexagon here. And let me add some other shapes to the canvas. I'm going to add a square. And there's smart snapping of tiles on PolyPad. So you can see here, as this square gets close to the side of the hexagon, it kind of snaps in place, right? You can feel it if you're doing it on your own. You can kind of see it here as well. So that snaps in place. I'm going to make a copy of the square and put it at the bottom. And now I want to rotate the square to get it onto the other side of the hexagon. And all tiles can be rotated with this black circle. So I'm going to click and drag on the black circle, and you can see that as I rotate it, I see the number of degrees of the rotation above that black circle. How awesome is that? So let me just zoom in a little bit. It also has smart rotation. So because these 2 tiles are next to each other, and a rotation of 30 degrees is going to be the one that will get it at the same angle as the side of the hexagon, it kind of snaps in place at 30, which is really great. So then I can use the C button to copy that. Let me copy one more and rotate it the other way. And now I've surrounded this hexagon with squares. Really nice. Now I want to add to my picture a little bit. I'm going to do a click and drag to select all of those tiles. Hit the C button on my keyboard and add this at the bottom. Zoom out a little bit. And 2 last features to show you about polygons before I turn it over to Ada is the join option. So you can see I showed you cut, which is how we cut the polygon. Join, when you have multi-polygons that are all selected, if you click join, which I'm about to do, all of these polygons are going to join together to make a single polygon. So I can click join, and they automatically become this one polygon that I can move around the canvas. I can rotate it. I can change the color of it. Let me change it to red. And then if I want to have students explore how many lines of symmetry in this shape, maybe I wonder if there's a line of symmetry right down the middle. So I could cut it like right down the middle. I could move it over. I'm going to flip it, right? And now I'm going to make it like a blue, and I want to make it transparent a little bit. And so I'm using this as an example to show you the flip action, as well as making shapes have some transparency to them. So I changed it to blue in the color picker in the toolbar. You can see there are some colors that are preset, and then there are some sliders here. And this bottom slider, the A, is where you change the level of transparency of a color. So I'm going to just kind of drag it to like 28% transparency. And now when I move it over to the red one, you can see it's beginning to show some purple, right? And if I cut it perfectly, which I did, it fits right on top into so that was a line of symmetry, right? And so for some students, for some adults, myself, sometimes I have trouble visualizing if something is a line of symmetry, right? The diagonal of a rectangle, is that a line of symmetry? And so to be able to cut it and then flip it and then put it on top and see what happens is a really nice feature. And the last thing to show, I'm just doing Command Z on my keyboard a bunch to go back to this. I want to go back to here. The last option to show with these polygons is Fold Net, which is really such a beautiful tool on PolyPad. I'm going to click Fold Net, and you might be thinking to yourself, that's not a prism though, right? You might see part of a hexagonal prism, but we're missing a hexagon. That's okay. You can still fold into something, right? How awesome is that? It folds into a hexagonal prism. It just doesn't have the top yet. There's a slider here where I could pause the unfold action at any point and click and drag to do a rotation. If I click unfold here, I go back to the shape that I started with, and now I can copy this hexagon and actually make a closed prism by doing fold net. Oh, it is. I have so much fun every time I do it. And then what I love, I can unfold it, take a square off and see what happens. Maybe I'll fold this one now. And now you can kind of see inside the prism, which is really a fun thing to do. So that was, in 13 minutes, a really quick overview of just what a canvas is, what all these toolbars are all about. And in the action bar, anytime you add a tile to the canvas, whether it's a polygon or a fraction bar, which we'll be talking about later, or some dice, pay attention to what's in the action bar. And just by playing around with putting tiles on the canvas and clicking what's in the action bar, you'll begin to learn some of the functionalities of the tiles. So now I'm going to turn it over to Ada, who's going to share a few more examples, just general PolyPad overview, and then we'll go back to those 4 categories that I talked about in the introduction. So take it away, Ada. And if Tim, we could do a swap of the screens, that would be great too.
Yeah, thank you, Dave. Let me start by asking a question. Here's a 1 to 10 multiplication table made with the number cards. Let me show you the number cards in here, which is locked. You cannot kind of move anything. And I'm asking, what is the sum of all the products in here? I would usually give my students some time to think, but let me quickly show you another representation for this question. Do you see the tabs in here, like tiles, file? Under the file menu, at the very bottom here, you see examples and templates. These are pre-made polypads that you can use as you wish. Let me check numbers and fractions. Here is the multiplication grid. And if you look at this multiplication grid, this time instead of number cards, let's zoom in a little bit, we are using number tiles over here to show each product, like 2 times 2 is 4 square. It's kind of the real magnitude, the real size of the multiplication table. So it's a huge square, right? So you kind of think that, yeah, I want to count how many square are there in here. So I'm going to select all of them. Again, the action bar. Very intuitively, I want to just click merge and see what happens. Here, I come up with all those squares now. I don't know how many, but I'm trying to make a kind of square by dragging the black handle in here. And after that, I am going to also use these number bars. Number bars are here. And also I'll merge them too, to be able to see the side length of this square. In fact, this side length is the sum of all the numbers between 1 to 10, right? So let me do this for this side as well. Merge. And this is simply a 55 by 55 square. And tell the truth, if you just click the number tiles at the bottom corner, you see it is 55 times 55. So now all I'm gonna do is finding the product of 55 and 55. And if you realize with this representation, not only question and not only the answer, but also the question makes more sense now, right? And to do that, I'll make a little cheating in here. Do you see the text box with the equation on it, x squared? So I get this. I'm just going to write 55. Then instead of the cross for multiplication, I am going to use the star sign on the keyboard. It gives me the multiplication sign for the equation editor and write 55 again. And what I'm going to do next is here you see the little toolbox. I'm going to click that one and say evaluate expressions. So by doing that, I'm going to convert this PolyPad to a calculator at the same time. So it calculates it for me. I don't need to do it. So now I know that the sum of all the products in the multiplication table is 3025. It's a nice one, isn't it? This is one of my favorite examples showing the importance of visualization and creating new models and perspectives to solve a problem. And the second thing that I want to talk about is the cube puzzle. This is like, I can't talk like endlessly about the 3D skills of PolyPad. And now what I did here is I used the polygons, these little rhombus in here. I created the isometric views, 3 isometric views of the same cube. I am giving 6 squares to students and ask them to create this cube. And you can give the template or don't, it's just up to you. And the kids will try to just create this one by just dragging all those ones next to each other in here. I don't care if I'm doing right or wrong just now, because students probably will fold it, look at it, and then unfold it many times. Most probably they will get frustrated and be challenged at the same time. But at the end, I am sure by like trial and error, they will figure out what is going on. Let me just try to make it right. And here is FoldNet again, and see what's going on. I guess this is the one. I'm using this black square handle to move it around the canvas. And then I'm just rotating it if all the isometric views are correct. Yep, that's nice, isn't it? And then one more thing. Let me just create a new PolyPad. Here there are 2 options, 2 little icons. This one is creating the folder, and this one is creating the black canvas, like new PolyPad. So I'm just clicking that one. I don't need to save this. Here again, I want to make a prism. I am getting the triangle tool here, triangle under the equilateral triangle under the polygons. And when I click it, under the settings menu, this gear button, the first thing is scale. It kind of shows the size of the triangle right now. It's 1. I want to make it like 3 times bigger, something like that. And then I'm going to go on here, and you see the little grid sign. I'm going to click it and show the grids. And I can also snap my triangle to the grid. Let me zoom in a little bit. Yes. And now the second thing I'm going to use is this blue rectangle over here. This is called the custom rectangle because you see down here, that corner, there's a blue dot, black dot that you can change the height or size of the rectangle. So this is the height I want, I guess that's okay. Now I'm clicking the rectangle. And again, from the gear menu, I can show the handles or hide the handles. I want to hide it because I don't want to change the size accidentally. So I did that. Now I am just copying again, getting this triangle in here, rotating it a little bit. You can see the little angle of rotation next to the handle. So it's 60 degrees. It means I'm doing okay. I'm going to get one more of this. And here, I can again turn off the grid. You know that I can select all of them and fold the net, but before folding it, I want to just change the transparency a little bit. So that when I fold it, we can see the inside of this triangular prism. Of course, you can make the entire prism transparent or only the base is transparent. This is up to how you want to wish that one. You can create all sorts of prisms, anti-prisms, platonic solids, and everything. But again, today I want to show you something else as well. You can also create cross sections. So here is a cube. Let me unfold it. And now I thought that what are the possible cross sections of a cube when I cut it with a plane? So I draw the nets of different possibilities. Now you can see triangle, equilateral triangles, isosceles triangles, like all sorts of quadrilaterals, pentagon, hexagon, and everything. Maybe, let me get this one. I'm copying it and creating again a new PolyPad. See, let me unfold it. For example, think that you're asking your kids draw the net of a cube cut by its 3 face diagonals. And to be able to do that, they need to use all the geometry concepts they know until that time, probably. Which faces to cut in half, what kind of shape they're going to come up with, what is the new shape, how can they create the size of this new shape, and maybe create the removed piece of the cube and investigate their volume ratio, something like that. Let me also very quickly get this out and unfold it to show you. So there are many possibilities in here. And one more thing, after they create the net in here, again from this right toolbar, do you see the export option? If you click that one, you can export this one as an image, even without the background if you choose the PNG image. And if you print it, you can fold it using paper too. So these are the last things I want to share for now, but just under this grid button in here, there are 2 hidden features of PolyPad. One is high contrast mode. This is if you want to show the edges, the sides of what you're drawing, whatever your polygon is. And that one is the hand drawn mode. This is really cute, especially my son really loves this. So I keep using it for him to create some nice figure and images. And I'm back to Dave.
Thanks, Ada. That's what awesome examples of allowing students to engage and play with math, where they're able to like create something and then fold it and then like see what happens, right? Like that puzzle where you're making the cube with colors is such a really engaging puzzle for students and really hard to get feedback on unless you're building it and folding it in PolyPad. So I think that's a really nice example of where these tools can be helpful. Tim, if you want to pull up my screen, that would be super helpful. Thank you so much. Awesome. He is on it. So now we're going to dive into examples in these 4 areas of where a virtual manipulative can add value beyond the physical. That cube puzzle example is such a great idea. That other example of Ada where she had the actual visual representation of the multiplication chart, and you can see the different sizes and then just merge them all together. I've never thought of putting all that together just to make a 55 by 55 square, and the visual allows students to see that. So in my teaching, I've really found amazing, been surprised to see how much PolyPad has helped students discover ideas for themselves. And so one example that I want to talk about is finding the area of circles. When I think back to when I first started teaching 20 years ago, it was just like, here's the formula, pi r squared y. I don't think I really knew as a teacher when I started. So we just memorized it and practiced it a bunch. And as I began to be uncomfortable with that, and I learned from my colleagues about how to really engage students in thinking about that, we had all sorts of activities, which was really me like doing some showing and telling, right? I had pictures on the boards and I was moving it around, and it was a lot better in helping kids understand the formula, but it never got to really as powerful as when kids could actually do it for themselves, right? It wasn't watching me do something. It wasn't watching an animation that was really an amazingly well-designed professional animation. It's still very passive. And the tools on PolyPad allow students to be the one doing the mathematics. So I'm going to go to a blank PolyPad and show you how I've done this in just beginning to have students think about how to find the area of a circle. At this point in my year, students are familiar with PolyPad. We have used it a bunch. So I'm going to show you this. Please know in class, my students would be doing it, right? You just might be sitting back and watching, which is great. But in class, students would be the ones doing what I'm about to do on the screen. So I'm going to go to the grid background that you just saw from Ada. I'm going to turn on the large grid. And first, I just want to make a square, an empty square on the canvas, not with the polygons. We're about a half hour in, and all we've done is show polygons. So let's go away from polygons a little bit. And I'm going to go to the construction tools at the bottom. So at the toolbar on the bottom, there are these construction tools. I want to make a rectangle just to start. And I'm going to make, let me change my color to black so you can see it a little bit better. I'm still on the blue from before, and I want to make a 6 by 6 square. 3, 4, 5, 6, and then down 3, 4, 5, 6. And this, I might have made for students in advance, and then I'm going to go over to the custom rectangle and use this black tab to make a square that is 3 by 3. And my warm-up for students is just like, how many of these little squares will it take to fill up the big one? But I would give this to them, right? So they, on their PolyPad, would kind of groan because they'd be like, oh, it's kind of obvious, but they would actually do it, or I would encourage them to do it, and they'd see it's 4. And I was like, great, okay, awesome. It took 4 of the little squares to fill up the big one. Wonderful. So now I'm going to scroll over a tad, and I'm going to make a circle with my construction tools. So I'm going to go to the circle, and I also want to make one that has like a diameter of 6. So there's my circle of diameter 6. Now I'm going to take the same square that has a side length of 3, and now the real exploration and question becomes, how many of these squares does it take to fill up the circle? And this activity I had done a couple years ago with paper, right? Students would draw the circle on paper, and then we'd cut out squares, and we'd have the glue and the tape. And as much as I thought my 7th graders might be into the craftiness of it, they weren't. They got annoyed by trying to cut, and it was hard to fit them in. But look how easy it is now, right? And now the focus becomes on the mathematics, not on the fumbling through the scissors and tape. So obviously it's going to be more than 1, right? Let's see, what do we think about 2, right? It's probably going to be a lot more than 2 of those. I'm just going to make that a different color. And then what about the third one, right? So now becomes the point where, is it going to take 4 is going to be too many, right? 4 of those is more than the circle. But the real question is, how does it compare to 3? 2 is not enough. 3, we don't know because we have this leftover space. And this is what I tried to do on paper with students, but now it is so easy just to take these pieces and cut them up. So I can take this and I can cut it. I'm actually going to turn off the grid background and undo that cut. You could see the cut was kind of snapping to the grid. I don't want that anymore. So now I do cut, and I have more flexibility as to where I stop my cut. So there's a cut. I can put that up here. Here's a cut. I'll put that one up here. And in a matter of seconds, I have taken all this blue stuff and cut it up into pieces to fill up the white space. Perfect cuts? No, not at all. There's some gaps here that are sticking out, right? Not perfect cuts by any means. But then I would do the same with the green and the red. And what's wonderful is my students would be doing this of circles of different sizes. So I did mine with 6. I would say make a circle any size you want. They would save their work. In a few minutes, I'm going to show you how to make teacher accounts and view student work. But in a matter of minutes, they're deeply engaged in thinking about how many of these squares are going to fill up the circle. In the interest of a webinar, I have made one in advance that I want to show you. And so here it is. And you can see this one was bigger and different colors, but it takes a little bit more than 3 of them, right? I've used 3 of them doing all the cutting. There's all this white space that is left over, which means it's going to take a little bit more than 3. So how many of these R squares is it going to take? Slightly more than 3. And then I dive into an activity on PolyPad where we take the wedges of a circle and we rearrange them into a parallelogram, and we cut that parallelogram to make it into a rectangle. I'm not going to do that on this webinar tonight. I'll show you in a second where you can find other webinars where I've done that example. But through that, students come away with this understanding that the formula is pi r squared. And it's not pi r squared because a teacher told me to, and that teacher used to be me, but they're seeing it's taking a little bit more than 3 of these r squares, that's an r squared to fill up the circle. And they come away with a really deep understanding of that. Before I turn it over to Ada for the next example, let me pause for 1 second to show you where to learn more about Mathigon and PolyPad. You can see on the right-hand side of the canvas, there's a question mark here. That's the help question mark. I'm gonna click on that. And the first link is to our help and tutorial page. And so in this help and tutorial page, there are some pages that you can learn about how to get started. with Mathigon. And then there's a detailed user guide for all of the tile types. So if we've shown you something in this webinar, maybe in geometry, and you're like, how did he get the net to fold again? You can click on geometry and it has a full guide of how all the tile types work. So those are our user guides. We have video tutorials on how to make classes and add students, how to customize PolyPad. I'm going to show you how to make classes in a minute, but there's video tutorials here. And then finally, the other tab at the top is a link to all of our webinars. So we do a number of Mathigon webinars. If you're interested in learning more about how I use the tools to prove that it's pi r squared, not that it's 3.2 r squareds or 3.1 r squareds, which, you know, here, I haven't proven that it's exactly 3.14159 r squared. It's just a little bit more than 3. If you want to see the next part of that activity, you could go watch our geometry webinar. And then, or if, you know, any subject that you're teaching, we have some webinars that are specific to that subject, so you can go check those out as well. So that is one example where the virtual tools allow students to come away with that they've done the math to see that the area of a circle is pi r squared. I'm going to turn it over to Ada for another example in this first category, and then I'll come back and talk about how to create students and classes and view student work. So that's the next part coming up. But Ada will do one more example first.
Yeah, thank you. Tim, could you please? Okay, thank you for sharing my screen. Here I have another problem, kind of famous one, the pool tiles, I guess, or the pond tiles. The first two steps are already given. You know, the blue ones are the pool tiles and yellow ones are around the pool tiles. And I can ask students to draw the next step, find the number of pool tiles and blue tiles and yellow tiles in the next, predict about the fourth one, then draw it and check their predictions, and make some generalizations to find out the number of tiles in the 10th one, like many exploration questions. And in here, I think creating the next shape is the most important moment of this exploration. I don't want them just to drag a point and the next shape just appears on their screen. I want them to create it from scratch like a physical manipulative, only using the technology for copy and paste. Let's start with the pool tiles then. Let's say a student just select the blue tiles. To be able to select multiple of them at the same time, you can press Shift key on your keyboard. So I select all of them, I guess. And now I copy and paste it here. Let me copy one more time to be able to create one more, the blue tiles. I guess I'm done with the blue ones. I can very quickly, under the algebra category in here, I have got coordinates, axes, and tables. I can get the table tool in here. I can use this table to talk about the blue tiles. For time's sake, I will very quickly 1, 2, 3, 4, enter 5. And for the first shape, I've got only one tile. For second, I have 4. Third, 9. My prediction would be 16, and so on. Maybe I can change the color of the table as well, right? Let's make it blue, so everything is nice and clean. And now the main thing in here is the yellow tiles, right? Let's say one of your students get these 4 tiles and copy them in here, and then one more 4 and rotate a little bit, and one more, and one more. So I've got 4 4s in here, right? You can definitely change the color to make your thinking a little bit like visible and to communicate your ideas better with the others. And this is just one way, and you can do this coloring to other tiles as well. And this student will probably come up with the idea that this is always 4 times. Let me just very quickly make this one right too. 4 times the number, the pool size plus 1. Okay, so again, let's use this little equation text box in here. Let's write, let me zoom in. 4 times, let's say they know about the variables and everything. Whatever our pool tiles will be, n plus 1. And this time, another child might think of like that. Let me get only the, let's get all those yellow again first, really quick. I might only look at the corners. The 4 corners are always there, right? So I can just copy and paste the 4 corners. And let's look at the rest of the yellow tiles. Here I have got only 1, the same with the pool size. Here I have got 2, 4 twos, again, same with the pool tiles. And here I have got 3. So the next one will be again, probably same with the pool tiles, right? Something like that. So this kid will probably think that, let me change the color of those. I have got 4 plus 4 times the number of the size of the pool, right? And again, with the equation text box, I can write 4n plus 4. I mean, they can write. So let's get another table for the yellow tiles this time. Let's get 1, 2, 3, enter 5 again. Let's make the table yellow. These are important stuff, you know. And in the first one, I have 8, right? And in the second one, I've got 12, 16, I got 20 in here. Probably the next one will be 24 because it goes like 4 by 4. And there are many other ways for students to show their work in here, show their thinking in here, explain their thinking. And after they figure out some expressions for each one of them, let me also write the expression for the blue tiles. Here, do you see the exponents button? I can just click on that, write n, and exponent square. Let's make this one blue too. And maybe I can get the coordinate plane. And you know, another magic trick in here is I can first, let me also write this one as 25. I can first click the table tool. Here you see the black handles. This is to change the size of the table. But here you also have a little blue triangle. So just literally get this triangle and connect it to the coordinate plane. So it plots the points for you. You can do the same thing in here. You can use different coordinate planes or the same one. It's up to you. Again, get the triangle and connect it. One more thing about the coordinate plane. You see the x-axis and y-axis, all those, like you can change the intervals. Let's make it 2, maybe 5, anything you want. Let's keep it 2 for now. And also, when you click the equations, which you wrote by this equation text box, you again see the same blue triangle. So get that connection and see that all the points you just plotted are on that line now. So I know that the equation, the expression, sorry, I wrote is correct. And in here again, the same. So there are many things that, I mean, they can also use algebra tiles to figure out in here. There are many things they can play with if we are talking about exploring patterns and making generalizations. And about this, I also want to show you one more thing. You know, there is like PolyPad courses and activities and lessons here. If you click on lessons, let me leave. There are a bunch of activities on this page. And at the very bottom, you can also search for it from here. We have got visual patterns. And For visual patterns, we have got like at least 20 different patterns that teachers and students can explore with their like answer keys, different ways of showing the answer and everything, different thinkings, even some 3D versions. So you can explore this one as well. So I am back to Diagram.
Thank you, Ada. That is spectacular. The power of using PolyPad for students to make their thinking visible to their classmates on visual patterns is really spectacular. I mean, I was just sitting back in awe of Ada going through the colors, and when she was changing the colors, I had a really clear picture of how she was seeing that pattern, and that's really exciting on a webinar, right? But think about how much more exciting it is when it's a student who is engaging with visual pattern and using the tiles in such an easy way to make their thinking visible is so cool. On the task page that Ada shared, there's a video that I've made about just like what Ada talked about, how to use the tiles to help students think about visual patterns. And I talk about an example. This was almost 2 years ago now when PolyPad was first out. And so I hadn't yet assigned the canvas to my students. I just had it up on my projector to be able to use as students were talking about how they saw the pattern. And a student was having trouble describing what the pattern was. And as soon as this was in COVID times, so she couldn't come to my computer. I was like, I want her just to come use my computer. But so she was telling me what to do on the PolyPad, and her classmates were in awe of this like amazing creative way that she saw a visual pattern that I don't think she would have like been able to communicate, or I wouldn't have been able to understand it in a way if I didn't have these tools up and ready to be able to do it. So such a really wonderful example. All right, I'm gonna take a little break from like all these cool examples, which could go on all night, and show you some of the teacher features. So thank you. Tim is always one step ahead of us. A round of applause for our host behind the scenes, Tim and Deirdre. There's Tim. Yeah, thanks, Tim. Tim's muted, though. He's trying to say something really nice about me, and he's muted. You don't have to interrupt.
I'm just saying, like, I'm learning so much I didn't even realize. This is amazing. Keep it going. This is awesome.
All right. Well, thanks for being quick on the screen. So let's say, my class tab is gone here. I did something to get rid of it, which I'll show you in a minute. So I'm going to spend maybe 8 minutes or so talking about how to engage with a number of the teacher tools. So I've made an account on Mathigon. Again, free for everyone. If you are new, if you joined a few minutes late, everything on Mathigon is free to make accounts for teachers and students. So I've made a teacher account. I'm going to go click on my picture in the upper right and go to my account settings. And you can see that I could change my account type to a student account. I don't want to do that, but I'm showing you this. If you first made an account and you made it a student account, a while ago to play with, and you want to change it to a teacher account now, you can do this here and change your account type to a teacher account. So I don't need to do that because I already have a teacher account. I'm going to go to my dashboard. So up on the top right, I'm going to go to my teacher dashboard. And I've deleted all my classes here. So we're starting from a blank slate. I want to create a new class. And I'll just call it, I don't know, ICTM webinar. If I can spell webinar correctly. There we go, webinar. So there's my class. No students have joined yet because I just made it. A number of ways to get students both into the Mathigon ecosystem with an account and then have them join your class. So the easiest way, if your school is a Google Classroom school, you can import right from Google Classroom. You would click on this, you would choose the Google account, and your classes that you've already made in Google Classroom will appear. You click the ones to import. Students automatically get a Mathigon account that is linked to their Google account. They are automatically enrolled in your class. Easiest way to do it. Not an option for everyone, so I'm going to talk about how to do it if you're not in Google Classroom. So the first thing you need to do is have students make accounts. And so on our at mathigon.org/learn, which I showed you a few minutes ago, there is a video on how to have students make accounts. If they are under 13, you can make a restricted account where they enter in your email as a teacher, and you'll get an email for every student that makes an account, and you just have to go in and click that you approve that account. So it's very easy to make a restricted account if students are under 13, or they can make an account with their Google login or with an email and password. So a lot of options here to make student accounts. If you need a student privacy agreement to be signed for you and your school to be able to use Mathigon, you can get in touch with us at support@mathigon.org, and we're happy to work with you to get those agreements signed. So let's say you've gone through all that, you've made all your student accounts. There's a video here on how to do that. And now you want students to join your class. So I'm going to go back to my teacher dashboard here. And here's the class that I just made. There's a class code. So I'm going to copy this code. You could put the code in your LMS. You could share it with students on the board any way you want to share that code with students. Now I'm going to go to my daughter's account. She has a student account. So I'm going to swipe over to another browser window. And you can see this is my daughter. So let's just go, I'll go to Mathigon here, just on the home page that a student would do. They would go in the upper right to log in. If they're not logged in, that's how they log in. And they would go to their student dashboard. And to join a class, she needs to add a new class code. So I've copied that code. I'll just paste it in. Of course, your students could just type it in, and I'm going to have her join the class. And so now you can see that I'm listed as her teacher. I'm also her parent, but under teacher and parent, there I am, David Porter. So she is now a member of this class. I'm going to swipe back to my teacher account. Here I am. No students here yet, but if I give it a refresh, there she is. There's Emily Porras in my class. She's done some work in our Mathigon courses. I've actually done it in her account. So this is showing me that she's done progress in one of our courses. So that's how you have students join. Now let me make a PolyPad and assign it to her, have her do some work on it, and then show you how I view it as a teacher. So I'm going to go back and forth a little bit from teacher, student, teacher, student. So I'm going to go to PolyPad. Here's a blank PolyPad. I want to show you some things in the number section because we have spent almost all of our time in geometry. A great sharing from Ada with the graphs and the tables. That was awesome. But let me, let me do some number lines because I really like our number line tool. So here is a number line on the canvas. I can extend it in a variety of directions. I can rotate it to make a vertical number line, right? I can change what the number line starts at. Maybe I want this one to start at 10, and I want it to have steps of 5. So there's one starting at 10 going up by 5s. Maybe I want this one to start at -8 and go up by 3 every time. That's fun. Maybe I'll do one more and I'll start at 2/3 and go up by, 5/3 every time it's improper fraction. So all sorts of great options with the number line. And maybe the tasks that I want to make, obviously this is a range of ages here, but maybe I want to have my students fill in some of the blanks on the number lines. And so I want to use this opportunity to show you our question builder tool. So I'm going to go all the way down to the bottom of this and open games and applications. And this is called the question builder. This only appears if you have a teacher account. So if you are on PolyPad and not logged in, this is not going to appear. Or if you're in a student account, that's not going to appear as well. But I'm in a teacher account, so I can put this on the canvas. And I use this black tab to make it a little bit smaller. Maybe I'll cover up this one because I want my students to figure out what that number is. And maybe I'll cover up, I didn't want to do a C there. I wanted to make a copy of it. Maybe I'll cover up the 16 and I'll cover up the 30 and maybe I'll cover up the 4. All right. So now I've put these blank questions on the canvas, but I, as the teacher, need to put in the answer here. So let's see. That is going to be 30. What's this going to be? What am I going up by? -3. What's that? -2. I'm going up by 3. So that's 2. That's 16. I think I gave myself an easy one as 4 here, right? Now, I have to save this canvas, and all these question answers are going to be saved here. So we haven't shown you how to save canvases yet. I'm going to go to the File tab. Tim, yeah, jump in.
Should that be a -2?
Probably. Oh, thank you so much. My arithmetic skills.
No problem.
No,
No,
thank
no,
you.
no,
At
it's
10
late.
p.m. East Coast time. Yes, thank you. I was hoping to make a
Good
mistake. There we go. That should be -2. Awesome. So I'm going to save this now. So I go to my File menu, and you can see this is called Untitled PolyPad. I'm going to call it Z number lines. I'm just calling it Z. So in my alphabetical list, it'll be all the way at the bottom. These are all my saved polypads, right? So I have a lot of ones that are saved. I've put them in folders. So I'm just doing Z here. So I click save, and it's all the way at the bottom. There it is. Z number lines, almost at the bottom. I have a couple other Z's here. And the other thing that I want to point out, when I clicked save in the browser, it attached this string to the end of the URL. So now if I just wanted to share this in the webinar, I could take this. I'm actually going to put it in the private chat to Tim, and Tim can go and paste this in all of our places here. But this is a really an easy way to share a canvas. I also could click right here, and I could get the link. So that is another way to copy the link. Sorry, I don't need to click here. I can just click right on this, and it says that has been copied. So if I just am making something for my colleagues and I want to share it, I can just grab that link right here and share it. But what I want to do is share it with my students, right? So I'm going to go to this class tab now. And you can see, again, this only appears when I made a class. I had a teacher account, but when I didn't have any classes, that didn't appear. Now that I've made a class, that appears. And so you can see the class I can assign it to is ICTM webinar. There are 3 dots here that would show other classes that I have in my account if I had more than one class. So I would choose the class that I want to assign it to. I'm going to click assign, and it says I've shared this with my class. Wonderful. So I've done this in advance or even in the moment in class if I want to. Let me swipe over to my daughters now. And I would tell my students, go to PolyPad and go to your file menu. And I would tell them to open their assignments folder. So this assignment folder by default is closed. So students need to get in the habit of clicking on the arrow to open that folder. And there it is, Z number lines. And so the students would double click on it. And you can see these blanks have question marks now, right? I typed in the answer as the teacher, but the students have to figure them out. And so, all right, I don't know, my daughter might know this is 40. Oh no, wait, it's not 40. I get this red X. It's 30. Oh, and I get this green check, right? And maybe we think this is 2, right? No, it's not 2. It was -2. But maybe she's having trouble understanding what the pattern is here. So I want to show you under numbers, we have these arrows, and maybe my instructions to students are really kind of show your thinking here, right? Make your thinking visible. So she could use these jumps and go to the pen tool and maybe just put a 3 up here. So those are going up by 3 every time. And then I could change that to -2, right? And so what's this going to be? 16. I hopefully get this one right. And this was 4. Awesome. And notice what happens when I get this final one right. Oh, this confetti comes down on the canvas. My students love getting the confetti. It is a really enjoyable, pleasurable thing for my students. They would work hard sometimes, even after class, just to get the confetti. So she's done this. They need to be reminded to hit save. We are working on some options where auto save will occur, but not quite there yet. So she has saved her work. She's done. I'm going to go back to my teacher account now and give it a refresh. And you can see that there's her canvas. And so if I wanted to share her work with the class, I could have either the student names appear or not. And I can double click on that. And there's the work that she did on this canvas. This particular one didn't involve a lot of work, but I just wanted to show you that anything gets added to the student canvas also shows up on your teacher dashboard. You can click on this one to see the assignment. This has the answers, but if your assignment didn't have any answers and you just wanted to share the assignment, you can do that as well. And so here I can see how my daughter did on that assignment. Yeah, great question. Do you see the mistakes that they made? So what I'm noticing right now is there's a bar here, and that bar typically shows some orange. That is an indication to me that she got some questions wrong initially, and that's not appearing right now. So I'm going to make a note of that to fix it. But there is an option to do a download of all the data of this assignment. And so that download will show me the number of attempts on each box and lots of data. So that is a way to get some more information here. But the other last thing in the teacher dashboard on the teacher dashboard to share is this is a particular assignment, right? But if I go back to my teacher dashboard and I go to this class, I can also open a PolyPad dashboard, and that's going to show me all of the saved canvases for everyone in that class. And so if you have your students are doing something where you didn't like make an assignment for them and share it with them, like that example I was talking about the area of circles, I don't give them a template. I just give them a few instructions and have them go and they start creating. So in those situations, I go to the PolyPad dashboard. I only have one student in this class. It's my daughter. I've been trying to keep her account kind of clean of all the examples that I've been making over the year. So there's only a few here, but these are all the PolyPads in her account. So I'm going to go over to her account for a moment, and you can see these are all the ones that she has saved, right? And so as the teacher, I have access to all these saved PolyPads. So if I'm having my students build some patterns, and you know the instructions are just like make some patterns with shapes and be ready to share, I could pull this up and I could share it with the class, right? Or I could go back to my dashboard and say, this is a canvas that I made in a webinar that had some number bars and clocks on it. And so I could share that with the class as well. All right, so that is a quick overview of our teacher tools. Again, that was a little fast, but mathigon.org/learn has a lot of videos, and these are short videos about how to do a number of those features. All right, we are halfway through, and it feels to me that that's a good time for a break. What do you think about that, Tim?
Sounds like a great idea.
All right.
You
Yeah,
guys
sure.
comments, it's amazing. So yeah. So it's
Awesome.
10:02 right now. We'll come back. Well, it's 2 minutes after the hour. We'll come back at like 7 or 8 minutes after the hour. Go to the bathroom, get something to drink, whatever. We'll be back here in 5 minutes.
See y'all in a few minutes. Thanks, Tim.
Yeah, see ya. Thank you.
Yep.
This is incredible. Holy smokes. Like I have tried to build this stuff as a teacher that like with paper pencil. Whew, this is way better. Way better.
This is
I'm loving it.
so much fun. So much fun.
So
I can't
much
wait
fun.
to see the second half. So
How did I not know about this before today, Tim?
It took me forever to get to Mathigon too. It took me way too long, but I'm glad it did. It's been growing on me every day. It's awesome.
I'm like, okay, I just rewrote my math curriculum. All right, cool. Thanks.
Exactly. All right, we'll be back in like 5 minutes. Okay, it's 8 minutes past the hour. I'm on, right? You guys, Dave and Ada, you are all doing awesome here. We're having a lot of fun watching, and we're learning so much. So this is amazing. I think you're muted.
Thank you. Yeah, thank you.
Sure. So who's up? Who's up next?
Me, yeah.
Let's
All
do it.
right. So I'll share your screen. Let's rock and roll. Have some more
Okay.
Mathigon fun. All right.
Okay, can I start now?
Go for it.
Okay, thank you. And one of the things that I like about PolyPad are like all the tiles here can interact with each other, like number tiles, also geometry tiles, fraction tiles. And this mix and match ability gives teachers and students to create and explore math in all sorts of possible ways. And while this can take quite some time and effort with the physical manipulatives, PolyPad here gives you the opportunity to redefine and modify your previous tasks. Here is one of them that I have been using in my class with paper and pencil. Now I have created this one with PolyPad. I'm going to use the number grids. This is, by the way, one of the most popular tasks in the lessons page. I'm getting the number grid on a blank canvas. And you see the black handles. You can change its size, but I need a 10 by 10 version. So when I decided on the size of this one, I'm just going to click the gear again, and I can send it to back because I'm going to put some things on it. And then for interactivity, I am going to, I can say cannot move, that's also okay, but I'm going to lock it so nobody can touch it now. And then with numbers, I am using the number grids. And with geometry place, I am going to use tetraminos in here. I'm going to get a few of those. But as you see, these are not exactly the size that I wanted. So I'm going to create a few of them again. And to do that, there are many ways, and I will show you, I guess, all possible ways, like one by one. The first one, as you can guess, is using the squares. I am going to copy and paste a few times, and maybe I can create the T tetramino in here. When I select all these squares, I have got the join option. Remember from today's first session. I'm going to make it pink and kind of increase its transparency a little bit. So when I put it on the number grid, I can still see the numbers under it. And then I can use the custom rectangle tool to create a square easily. I showed you before, but here you can hide the handles. I am going to make it yellow, like in the original tetraminos. And again, let me get the transparency a little bit in here. And one final, maybe I can get this L shape as well. This time, let me use the custom polygon. And to tell the truth, this is the one of the tools that I've been using most. And let me just zoom a little bit. I am going to select all these points one by one and snap them on the corners of the grid. Here, for example, I don't want this one, so I click on it and it disappears. I have created the L version, and now I need another point in here, so I just click. Another point in here, I click again and drag the point down, and another one in here. See, now I realize that I don't need this point, so I just click to make it disappear. Here is my L shape. After I made it, I need to fix the vertices, so let it stay as it is now. And let's increase the transparency a little bit and put it here. Okay, now I've got everything I need to altitude. And when I do this in class, I usually start with a magic trick. I ask my students to place any tetramino they want anywhere on the grid and tell me which one they use and also the sum of the numbers. So once they tell me the sum, I immediately tell them what are their numbers are, and therefore where are their determinants. So they got all surprised, and then it is time to explore how did I do that trick? How can I do the same thing, maybe, and the better things with this new skill? So before exploring more on this task, I want to show you again. This is under the activities page. If you just write the search like Tetramino, there are, for example, 2 different tasks in here. The ours one is Tetramino equations. You see all the explanations, solutions, like sometimes videos and everything. And even some more exercises and some support and extension, everything you need is here. And now, if you follow Desmos or Mathigon, you know that this was like breaking news of the last week, kind of broke the math internet. And if you're not familiar with, from now on, the PolyPad will be in Desmos classroom. So if you are not familiar with the Desmos classroom, don't worry, because the next webinar is all about Desmos classroom. Probably Tim will share the link right now. And in Desmos Math Classroom, let me very quickly show you. You can create your own activities. Here are the custom activities. Let's say create a new one. Let me very quickly write the name, create the activity. You know, for each page, you can just choose anything you want. And now, there is PolyPad in here, like graphing calculator and the card sort and the polygraph. PolyPad is the only component allowed on the screen. And you can write a title, PolyPad, and you can just do the same things in here again. Number, like number grids, get this one out and go to geometry. Maybe this time get some polygons out. Everything you want to use is in here too. Almost everything. And updates will like come, I'm sure, in very near future. But now I want to show you the same lesson in the Desmos classroom. So this is the lesson. There are many screens in here, but this is for you just to pick up the ones that you would like to use. In the first screen, I'm just introducing the tetraminos. And second, third, I'm just doing the magic trick thing. And here, students start exploring. Like they can call any number a variable like upper right number usually, and then they try to express all the other numbers in terms of n. In the next screen, after they do that, they're gonna find the sum. The next screen, if they can find the sum, when they know one of the numbers, and when the sum is given, if they can find the number. So it will go like that, and they will try different ones as well. Here, this one is quite straightforward because it goes by like n plus 10, n plus 20. Here, maybe you may ask, if we change the size of the grid, what happens? And they've got like the other tetraminos as well, as you see, and like change the number of grids. And even the size of the grid can be anything. There's a video over here that I keep changing the size. So they'll explore lots of things in here, and like you can see their thinking, how they are working on the different expressions, how they create equivalent expressions and everything. It's real time. And now I am ready to be back to Dave.
Thanks, Ada. Yeah, we are so excited to have PolyPad as a component in Desmos Classroom. And I think Tim just put the link for the Desmos Classroom webinar on Thursday. So go check that out as well. That example, I think, was a really great one about allowing students to move from concrete to abstract at a pace that they're ready for, right? The abstractness of an algebraic equation, when you're seeing it on a number grid in a tetromino, oh, it's going up by 10 every time. Yeah, 10, 20, 30, 40. How can I represent that algebraically? And allowing them to move to that abstract representation when they're prepared for it. And so I want to show another example in this category, showing off some of the number tools and more geared for elementary students. So here I am back on a PolyPad. I just added equation 137 plus 285, and I want to show you how we can use some of the number tiles to have students really build some deep understanding of what's going on with these numbers in base 10. So I'm going to do an example with our number tiles and our number cards to show how these tools work. So I like giving students as blank of a canvas to start with as possible. So I've taught middle school. I haven't taught this exact task with students, but I imagine if I were, I would, after they have some comfort level with the tiles, would just say, go build these two numbers with the number tiles. And so here, this is a green block that is a 10 by 10 block. So there is 137. There is 100, and now I need to get a 10 block. So there is 10. I'm going to copy it to get to 20, copy it again to get to 30. So there's 130, and here's the 1 block. And I'm going to copy that a whole bunch of times and use my arrow keys to move it up to get to 7. So there's 137. A quick aside on our number tiles, there's a black handle here where when you click and drag that black handle, it changes the arrangement of that number. So you can see I've taken that 100 block, and I've now shown that you can take 100 and arrange it into 5 groups of 20, or I can arrange it into 8 groups of 12 with 4 left over. So another way to use the number tiles is explore factor pairs and remainders and all sorts of number theory ideas. But for here, I want to show 137 plus 285. So there's 200. Let me get a 30. Another 30 is 60, right? And I need another 20. And just this task of building the numbers, I think, as I said, is a good task for students to engage with, right? How do I build this number in the number tiles, right? So now we want to add them together. So I'll take the 7 and the 5 and just kind of put them on top of each other. I haven't really done much now, but as you saw from Ada in the beginning of the webinar, you can merge these number tiles together. So I'm going to do a click and drag here and select merge. And now it makes one group of those. And with this black handle, I can get it into a group of 10 with 2 left over. So there's my 10. I'm going to click split. And now I can take this 10 and move it up here. So now I've added that 10 with all the other 10s. Now I'll do a click and drag to merge all the 10s together. Again, I'll take this handle to show the number of 10s. So there is our 12 groups of 10. I'll split it and take this big box of 100 and move it over here. And maybe merge that together and make it green just so my colors are consistent. And there I've shown 137 plus 285 is 4 hundreds, 2 20s, and 422. And that's really concrete, right? You see the 100 block as 100 of those tiles. So for some students, working really concrete in this way might be great. For other students who are ready to abstract that idea a little bit more, our number cards could be helpful. So let me... I could build the numbers 137 with the number cards, just like I did with the number tiles, or I could type them in. And so I'm going to type in 137 and 285. You can see that these are in green because they're both above 100. Let me scroll down a little bit so I can zoom in on the number card. So here's 137 plus 285. And so some options with our number cards that I think can really help students think deeply about base 10 is the ability to split. So I'm going to click on the 137 and click split. And you can see when I do that, I get 100 and 30 and 7. And then we can split the 30 into 3 10s, and I'll split the 7 into 7 1s. So there's 137 broken up into their base 10 representations. I can do the same over here. I can split all of these at once now that I've done it once. So there's all those numbers. Students could now take these hundreds and move them around if they like, or there's an option to select them all and organize them. And when you click organize, the hundreds, the tens, and the ones are all grouped together. Really nice. And now, just like I did with the number tiles, right? I could be doing both of these at the same time. As you recall, there was a group of orange number tiles that was the 10 and the 2. I can merge these to make a 10 and move it over here, and merge these to make 100 and move it over here. And I could just get all of those and merge them together to get 422. But the final thing I want to show you here that I think is nice as well, when you're ready to begin thinking about more of a movement towards an algorithm, you can take the 137 and the 285, and let me do a split and a split. And so now I can line them up kind of vertically like that. I certainly could add the 100 and the 200 first, but if we want to get students beginning to think down the road of how we represent addition of numbers, I could take the 7 and the 5 and get 12, right? So I like that stays at 12. Now I want to go here and split this, and I can see I have the 10 and the 2. Maybe you want to put that 10 up there, right? And now we can put the 10 and the 30 is 40, 40 and 80 is 120. I need to kind of split that up into the 100. I split that up. Let me put the 100 up there. Oh, I hit delete by mistake. A quick Command Z on my keyboard undid that. There's the 20, and now I can put these all together, right? And if I wanted to, I can go like that to get 422. So really nice way to have a progression of moving from the concrete to the abstract in thinking about addition of numbers. So that is super exciting. I'm going to show you one more thing before I turn it over back to Ada, and that is our balance scale. So one of the most popular tools on PolyPad is the balance scale. So I'm going to go to the algebra section, and it's under the balance scale. So I'm going to put this scale on the canvas. I'm pretty zoomed in, so let me zoom out a little bit. And what is really exciting is so many, in fact, almost all of our tiles can work on the balance scale. So I could go to numbers, and I could put a 10 block on one side of the scale, and then I could go to our number bars and say, let's see, a 4 and a 6 should balance that 10. Oh yeah, and of course it does, that works. And then maybe I go to our number frames here. We can see we have 10 frames, which I can expand into a 20 frame or a 20 frame in each direction. I could fill it. I can double click on that to change the color. But we also have these number frames, right? So here's a 6 and an 8. That's going to make that side too heavier. So let me balance that with a 2 over here. So that should balance things, right? We have these prime factor circles. If you played the game Prime Climb from Dan Finkel over at Math for Love, these prime factor circles are spectacular. You can pull a number apart into its prime factorization and then put them back together if you like. So let me put 6 over here, and then let me go back to the number cards and put 6 over here. So that is super exciting and engaging for students. We have dice and coins that work on the balance scale. The coins don't have a value. The dice have value, so I could go to probability and data, and let me get a couple dice here. I'm going to put 2 over here, and then let me copy and put 2 over here. It's balanced right now, but what happens if I roll them at the same time? What are the chances they're going to stay balanced? Oh, I got an 8 and a 10, so that side is heavier, right? And so the fact that these change in the moment is really exciting and engaging for students. So many options of things you can do with the balance scale. I'm going to go to our task page, which you saw from Ada a few minutes ago, and just show you some ways where you can learn more about the balance scale. One of my favorite tasks to connect with this age student at the elementary level, I'm going to open balance scale polypads, is this first one, or it's the third one in the first category, where there are a number of scales that are unbalanced with different numerical representations. And the task for students is just balance the scales in any way you want. And I like that this task, again, has a lot of these different representations of numbers, and students have the freedom to go to these number tools and balance the scale any way they want, right? So good opportunity to have them share the way they're thinking about the balance scale. So that was in the task page under balance scale polypads. It's the third one here. I'm now going to show you how to use the balance scale and the algebra tiles to create situations where students can use the tools to think deeply about how to solve equations. So I'm going to just go to a blank polypad, put the balance scale on the canvas, and show you our algebra tiles. So let me put an X tile here. And the X tile always has a starting value of 5 on polypad. I think when we were first building these algebra tiles, it was the same length as the 5 number bar. So we picked that it balances with 5. So you can see that balances right now. But we clearly always don't want X to be 5. We want to be able to change the value of X. So I'm going to go get a pre-made canvas. Our link for tonight is mathigon.org/talk. And this is where we post links for a number of talks that we give. Here is our Iowa Council of Teachers of Mathematics. And I'm going to scroll pretty far down to a tape diagram. Here it is, using the balance scale. So Tim, I'm sure, will drop this in the chat. But here is a type diagram that I made for my students this past spring. And this was after working with the balance scale for a while. So they understood all the features of how to do this. But my task for them was build exactly what you see on the balance scale, thanks Tim, and then use the tools to solve for X. And I picked this one at this point in my students' understanding of the balance scale and of solving equations, because the answer wasn't obvious to most of my students. So let's do it. They would go to algebra. Again, this was after a lot of work with the balance scale on tape diagrams and equations that were much simpler, but I want to just share an example that's a little bit more complex. All right. And they knew that their first task was to make it look exactly like what they saw in the tape diagram. So they would do 3x and 2. And I didn't make them change the color, but if they really wanted to, they could make that green. And then let me copy this because there's 3 of them. And again, as I was talking about with the number tiles, I think the act of doing what I'm doing right now is an important skill for kids. Okay, here's this tape diagram. What does that look like as an equation on the balance scale? So here's 40, and here's 50. And when I put the 50 over here, oh, it doesn't balance. Of course it doesn't balance because I mentioned a minute ago that the starting value of X is 5. Let me just make that red to fully match the tape diagram. And 3 5s is 15 plus 2 is 17. Well, it's 3 17s is 51, and that's 91. So it probably balances with 91, right? Which is not what we want, right? That'll balance, but that's not what's happening here, right? It's balancing with 50. And so the key action here, when I click on the balance scale, notice there's this option in the action bar that's called balance. And when you have an unbalanced scale and an algebra tile on one side of the scale, when you click balance, PolyPad will assign the value to that algebra tile, to that variable that will balance the scale. So I'm going to click balance and watch what happens. Oh, right? And I've trained my students to make that sound when they balance the scale because now there's some like mystery value of X. I would go through it where students would do the algebraic notation on the screen so they'd have a record of the steps that they did, but just in the interest of time, maybe we put the 2's together to make 6 and we just move all the X's over. So I've just done the distributive property without talking about it, right? There's 9x plus 6. Again, they'd be writing that on their canvas. Let's put the 6 and the 40 together to make 46. We're combining like terms. If I try to combine this, it doesn't make 55x, right? It's just 9x's and 46. And now let me try to move this over here. Oh, wait, that gets unbalanced, right? Because I can't just take 46 off this side and move it over here. I like to talk with students about putting the same thing on both sides, right? So let me copy this and do a negate to get negative 46. And I'll copy it and put it over here. So now I've put negative 46 on the same side, on both sides of the scale, and it stayed balanced. And what's really nice here, when I put the negative 46 on the 46 and let go, it makes a 0. And I really like that that gray 0 stays there, because that's the goal here, right? I'll talk with students about what could we do to make this a 0, right? We want to make this a 0. Oh, we could get a negative 46 here, but now we got to put it over here to keep it balanced, right? And so there's the 0. You can now delete the 0, right? But I like that students have to actually delete it. They'll see it, and if they want to get rid of it, then they can hit delete. And I put these together and show that it's 4. So 9x's is 4. We could put out some fraction tiles to show how to take 4 and split it up into 9 groups. But we know that 1x is 4/9. So I will just show you that this will balance. Let me get some of our fraction bars here. We haven't even shown you the fraction bars tonight. And there, that is 9/9. That's not going to balance because it's only 4/9. There is a slider here that can change the number of pieces that are shaded in. So I can leave it at 4/9 like that. It'll balance the scale. I could also use this black tab here to just have 4/9, and that'll balance the scale as well. The last way to balance the scale with a fraction or a decimal is under the equation tool. I can just type in a fraction of 4/9, and that'll stay balanced as well. So there it balances with 4/9. You can see PolyPad is evaluating that for me. It's showing me that that's 0.44444 as a decimal. As you saw from Ada a while back, you can turn that off in the Customize UI menu by unchecking Evaluate Expressions. All right. The balance scale is such an awesome tool. The last thing to show, and then I will turn it over to Ada. Even things that you don't think can have values on the balance scale do. So like our polygons, all of the polygons have a starting value of 1, but you can assign values to them as well. Just like I assigned a value to X, if I click balance, now this blue square on this saved canvas, right? I would save this canvas. Anytime a blue square is now used on this saved canvas, it has a value of 4. And so many wonderful tasks and explorations can be made with assigning values to things. In fact, you can assign values to imported pictures. So let me just show this. I'm going to go back to our task page and show building balance scale puzzles. So here's an example of a balance scale puzzle that I made. I made this at the beginning of the year for students to learn about me a little bit. I took a little screenshot of myself and other pictures that I saw online. I just dragged them onto the canvas. And just like I assigned a value to that blue polygon, I assigned a value to these images, and then I built this puzzle. And then I had students build puzzles about themselves, and we all shared them with each other, which is a nice way to get some algebraic thinking in, as well as the class all learning about each other. So definitely dive into the balance scale. Under algebra, there is a question mark here. In fact, next to all of the categories, there's a question mark that goes to the detailed tutorial page on that. So with that, I'm going to turn it over to Ada, who's going to share some more fun things with the balance scale.
Thank you. I know that we've got like 20 minutes of time, so I'll be trying to really quick in here. Let me show you. This is the first thing that I want to share. This is just very straightforward, no variables, no unknowns, no algebra in here. In fact, that's the famous grocery puzzle, the weight puzzle. You can ask high school students maybe this version. You open a new grocery and you want to buy the minimum number of weights, and you want to be able to weigh things from 1 pound to 40 pounds, just with whole numbers right away. What is the smaller number of weights you need to purchase, and what are those? But instead of using that version for now, for my middle school classes, I'm going to use this version. So I'm giving here 1, 3, 9, 27, and I'm asking my kids, can you balance all the numbers 1 to 40 by using those? So ones are easy, right? You put just 1 in either side and it's balanced. 2, let's very quickly have a look at. If I put 2 in here, maybe 1 next to it, and 3 on the other side, that is balanced 2. 3 is very easy. So 4, how we do 4? Like that. And how we can do the 5th one? Any guesses? something like that. So the kids will add and subtract one after another to keep balancing all the numbers in here. And one more thing I want to show you, although they already told you about these, I just want to show you one more time. When you try to create like simultaneous equations or the system of equations, the first thing you need to do is defining the value of the variable. I mean, do not directly write the equation, but instead define each variable one by one. Let's say these are the two that I would like to use. I'm going to go back and see the number cards. Let me use 6 for the circle and 9 for the diamond. I am going to balance this one and this one. So that the specific polypad knows that circle is 6 and the diamond is 9. Now I am ready to create any equation I want. I'll go really basic. The sum of x and y is 15. And also, oops, let me just again copy and maybe one more diamond. And sum of that xn plus 2y is 24, right? And when I do that, you see it automatically balances itself. You don't need to do anything else. So they're already there. And now you can share this file with your students and they can try to solve. Probably the first thing that they're going to do is changing the color of the scales because it's too boring with the gray color. And then they can start thinking about how to solve for those values, how to figure out those values. They can do many different things, like, let me just copy the balance scale here. Maybe they can add them side by side, like here, and let me get those in here. Also get this one and this one, copy, and in here. I'm not gonna show everything because we don't have enough time, but you can definitely solve it by like adding side by side, subtracting side by side, or substituting the values, using algebraic tiles, or like writing the equations and plotting them on the same coordinate plane. Like, for example, in here, the sum of these two is 15. So every time they see, let me just copy and paste a few times. Every time they see this pair, they can replace it with 15 and another 15 in here. They can merge. There is 30 in here. And it's, I mean, the balance is still there. So they're on the right track. They can, it is just auto-checking their process all the time. They keep balance all the time. So let me just copy 30 again. I need to negate it, as Dave said already, to be able to subtract it. So I'm subtracting from both sides, and the great sound effect, and voila, I found the value of the diamond. I can definitely go back and find the value of the circle as well. So again, in the lessons page, there are many activities about the balance scale polypads, balance scale puzzle, and simultaneous equations. Let me very quickly show you. It's here with all sorts of examples. Let me very quickly show a few. Here again, there's a system of equations where maybe younger students can solve, like they can start with this one, and after finding the circle, they can move on to this and that, or they can use this one and just comment on or compare the different variables and different quantities. And this one, which is my favorite, like they just said, you can import images. I hear important Yoda and Anakin, and they are trying to bring balance to the force. But here there's a restriction. They can only clone themselves. So this is all about greatest common factor, least common multiple, and all sorts. They need to clone themselves to be able to create the balance. Like how many Yodas you need to make a balance with Anakin, and so on. Okay, I need to stop here to be able to talk about the probability and data tools a little bit. So I move on to a blank document here. Let me very quickly show you. like the coins. We have got dice, coins, random number generator, spinners, uniform and non-uniform ones. This is like equally likely events. Just drag the point around the circle to create new slices. Here you can change the size of the slices as you wish. This is the random number generator. Again, by clicking this gear button in here, you can change the minimum and maximum number, the way they choose to randomize, the numbers. Here you can see the nicest sound effects when you roll the dice or flip the coin. But now I'm not gonna use these ones, but instead I'll start with the dice, a die, in fact. Let me very quickly copy and paste a few of them. Like, as you can see, it's like in seconds, I've created 10 dice. And if I just, copy it one more time, let me fix it. One more. You see where I'm going here, and one more. I got 100 dice. It means every student in my class has now 100 dice in front of them. So can you imagine the size of the data that we're going to produce together? So once I roll it, I'm also going to tabulate it. A nice table shows up with the counts of each number, like there are 18 ones, 10 twos. So I'm going to roll again. You see the numbers are changing, but it's kind of replacing the outcomes of the previous roll. So instead of doing that, I click the table again from the action bar. If you realize everything is in the action bar. Instead of the replace option in here, I'm going to choose the cumulative version. It's going to add on top of each other, kinda. So let's roll again. Let's roll one more time. Did I just roll like 300 times? I guess when it comes to experimental probability, the size of the data does actually matter in here. So when you click the table, you also see different graphs. I'm going to go on with the pie chart. And it's almost like 6 equal regions, right? Can I get the 1/6 and add some transparency to be able to check what is going on with my outcomes? Oh, almost, what a chance. Look at this. It's not chance, it's experimental probability, in fact. So after that, I also want to show you, like, you don't need to even copy and paste those dice over and over again. Under the probability and data, you've got 100 coins, very quickly, that you can select, if I can. You can select and flip at the same time, tabulate data, and also, again, make a little circle, pie chart, sorry, flip again. And you see you've got spinners, playing card templates, and everything. Before, if we have time, I've got one more thing to show, and that is this little game. In fact, there was an old British TV show called Countdown. If you remember that one, there was a big number at the beginning and randomized by the host, and there are like 5 or 6 other smaller numbers where the contestants simply use for operation with those numbers and reach out to the bigger number. I saw the same game on the Math Games book of Ben Orlean, which is my favorite book nowadays. So he was using only the numbers between 33 and 99, since we are using dice in here. So just hit the randomize button and roll the dice and try to get as closer as you can to this number. So when you've got this many tools for probability, like coins, even we have got like Dungeons and Dragons dice in here. So you can create any game you want. I'm back to Dave again.
Thanks, Ada. It's so fun to watch. We are coming close to the end. I was so excited when I first heard from Tim that it was a 2-hour webinar. I was like, we can show so much. Our webinars are typically an hour webinar. And even in the 2-hour one, I feel like we are pressed for time because we have not gotten through everything we want to do. But I hope I have a few more quick examples to share, and then we can open it up for some questions. But I hope that like one takeaway from this webinar is there is so much to explore, right? I just want to point out we haven't even talked about variable sliders, and I'm not going to get to them in this. We have a whole logic and computing section on PolyPad to make circuits and music with metronomes and different sound effects, logic gates, amazing things to explore. We have currencies. We just added Canadian currency, clocks, and dominoes. And so just begin exploring, right? Put some tiles on the canvas, see what happens. Anytime you see that blue little triangle, pull out the wire, see what you can connect it to. In our probability and data section, we have a number of chart options, some of which you saw from Ada. But we have box and whisker plots, which I think there's some great ways here to explore box and whisker plots. And 2 links just to give a final plug to, and then I want to show you something about probability and prime factor circles. One link again is in the help menu, which is mathigon.org/learn. These user guides and tutorial videos can be really helpful. Up at the top, there is a link to our webinars. You can go and watch a deep dive into a specific topic if that's of interest to you. And then finally, our task page, which we've seen a few times. You could search by a topic, right? You are teaching fractions and you want to know any topic here that is connected to fractions. Give it a search by fractions. Maybe you're doing mean, median, mode, range, right? We have a couple of things there. So give it a search, give it a scroll, and see what you got there. 2 final things to share, one in probability and one with prime factor circles. Here I am at this link that you can find from mathigon.org/talk. And I want to share this one, which is free throw simulation. This was this was a question that came up to my students at some point last school year. It was on a math contest, and we hadn't done probability yet, so they really struggled on how to make sense of this. It says that that Jorge makes 75% of his free throws in a basketball season. What's the probability he misses exactly 2 of his next 3? And so, not surprisingly, we hadn't done a lot of probability, and almost all my students got this wrong on this math contest. And we also have this standard in 7th grade where students should be able to design probability simulations and use the experimental probability to create some understanding about the theoretical probability. So I made this canvas for them. I shared it with them. You might notice the tile menu's gone, right? There's no tile menu here. And so I knew that at this point in the year, my students love playing on PolyPad, that sometimes I give them a PolyPad and they are just too distracted by everything else. So there are ways to really customize what you want to have appear on a PolyPad. I'm not going to show you how. I'll just show you where you can learn more about it. It's under the tools here called Customize UI. We've shown this a few times by turning on and off evaluate expressions, but you can see I've unchecked the sidebar. So this was turned off, and almost all of the actions are turned off, right? Except for randomize, which allows them to roll the dice. So like they can roll the dice, they can't delete them, they can't copy them, they can't do anything except roll them. So I told my students that let's have a 1 represent a miss and a 2, 3, 4 be a make. And that represents that Jorge is making 75%. 3 out of the 4 are a make. And so I would take 1 and I'd roll it. And I would ask them, okay, what happened here? And this would be make, make, make. And then I'd roll another. And then they would say, that's also make, make, make. And they got it. And we talked about it a little bit. And then I'd say, okay, take 50 and roll them. And go through and count how many have, what are we looking for? Probability he misses exactly 2. How many have 2 1s? So let's see if I can find one. Here's one. That's miss, make, miss. There's one with 2 1s. Let me find another one. Here's one with 2 1s. Great, we got it. And I think I had them do it 4 or 5 times. I think 4 times each. So in a matter of seconds, and it was like a joyful seconds. They had fun. Like, it's kind of fun to do this, right? It's fun to like see them all rolling and counting them all. They shared their data. I put it on a Google Sheet. So you can see here's all the data that I got from a class of 26 students. They were telling me how many of the 200 had exactly 2 1s. And so this student, 22 of the 200. In fact, as I'm having students keep track of the data, this, there's a pen tool here. So, they may be on the first one, they'd get 8, and then they would do it again to keep track of their data. I put all this together in the moment just with the sum features on a spreadsheet. And we did this in a matter of 5 minutes. We got 5,650 trials of this simulation, which came out to an experimental probability of 0.1384. And after that, we were ready to have the good conversation about what the theoretical probability is. And I just asked students, find some ways on your canvas where 2 1s appear. And so they would say, oh, there are times it's like something 1 1. There's times it's 1 1 something. And then there's times it's 1 and something 1. And so we said, okay, how many ways could that something be? And they each have 3, 1, 2, 1, 1, 3, 1, 1, 4, 1. So there's a total of 9. And then we eventually got to the point that there's 64 total ways that the dice can land. So that got us to 9/64, which is pretty darn close to what we got. It's 0.1406. And so by doing this, they really believed that our experimental probability, our theoretical probability of 9/64 was the right one, because look how close it was to our experimental probability after 5,000 trials. And so as Ada was talking about, I think this ability to create large data sets really quickly where students are seeing all the results, I think it lends them to believing that it's true. Certainly you or your students could write a computer program, right, that says, take 3 4-sided dice, roll them 1,000 times. How many of them have exactly 2 1s? And it could spit out a number. And that's a really interesting thing to try to code. But I think for students who are focusing on the probability, to be able to see it happening and look at all the different results, I think that adds a lot of power to their understanding of things. Awesome. We did not get through all these examples as expected, but go explore. Go to mathigon.org/learn. Get in touch with us if you have any questions. I'm going to go to the end of the slideshow and show you all of our social media channels on Twitter, Facebook, Instagram, TikTok, Pinterest, our YouTube channel. We love seeing how teachers are using the tools. So please share and tag us in your posts and offer suggestions. It's been a real joy to be a part of the team that's been improved this tool over the past 2 years. And our best suggestions come from teachers, right? Teachers who are using the tool in the classroom and have ideas. We love hearing those ideas. Our email is up there as well. Feel free to send us an email. Tim has offered many ideas, and they're always wonderful. I think Tim knows the ideas don't often go as quick from idea to appearing on PolyPad as any of us would like. And so we appreciate your patience when you have good suggestions, but it is always great to hear ideas from teachers. So with that being said, I don't have any dates to get to despite what's going on in the chat. So if we have any questions that people want to ask, we do have a couple minutes for questions if people want to chime in. There's Tim and Deirdre. And thanks again to the Iowa Council of Teachers of Mathematics. It's really an amazing series that you've put together, and the amount of math teachers that are coming to these across the world to learn about these 4 awesome tools is really inspiring to see. So thanks to the both of you for your planning and organization of this.
I'm just so excited that ICTM could sponsor this. And I started year 30 today, and I'm more excited to go back tomorrow than I think I have been in a long time. This is fantastic. So I can't wait to see what my kids can do with this. I'm sure once I turn them loose, they will teach me a whole lot of things. So that's how it usually goes.
Yeah, just as a quick story, there's a way to make tiles invisible, which we haven't talked about. And I was having my students build puzzles on the balance scale for their classmates to solve. And so a student of mine, he made a balance scale and no one could solve it. And he told me that I broke PolyPad. I did it. It's not working. And I got nervous because the tool wasn't working as designed. And he was chuckling the whole time. And I couldn't figure out why. And finally, it dawned on me what he did. So, under the grid, here on PolyPad, there is a way to show any tiles that have been hidden. And so he had 4 tiles on the balance scale that were invisible, that was messing up the whole thing. And it was wonderful, right? It was a great moment in class. We all had such a good time with it. But yes, Deirdre, kids will break it in fun and surprising ways.
I've learned a lot from my students about all the platforms, GeoGebra, Desmos. Like, you just let your students play for 5 or 10 minutes. You can learn so much more from them in that time. And
Definitely,
it's amazing.
Yeah,
It really is.
I also want to thank all the engineers and all the teachers and everyone that makes PolyPad exist for us, and also to you guys inviting us here, and everyone who is listening and joining us today.
Well, thank you to you two for facilitating an awesome webinar. It was absolutely amazing. So we have the links there. And so what I'll do, especially, on the one on my YouTube channel, I'll put the links to the slides and everything like there. So it's all in one place in the YouTube description. With any last words, Deidre, Dave, or Ada, then we'll sign off.
I really appreciate Dave and Ada coming on. And I think Tim has said you're going to make a curated playlist, right? With all 4 videos and the links all together. And those will be housed at iowamath.org starting probably sometime next week once we get everything all put together and on the website. So if you missed any of the webinars, like you tuned in for Mathigon and you want to know really more about Graspable 2, hey, it'll be at iowamath.org. So you can find it there. You can find it on all the YouTube channels that you guys all have, Facebook channels, Twitter, right? TikTok. You guys are everywhere.
Yep. The links are everywhere. So thank you so much for joining us. We hope you have a great evening, have a great morning, wherever you are in the world. And don't forget to tune in or check it out on Thursday night. Kathy Henderson and Nick Corley will be in the house to show us the awesomeness of Desmos Classroom, which Mathigon PolyPad is now a part of. So, which is really cool. So again, thank you everybody for joining us. Thank you for all the comments, the questions. We hope you have a great day, great evening, and we'll see you back here on Thursday night.
Thank you.
Bye-bye.
Bye, everyone.
Bye.